AI agents need MCP, but MCP doesn't need AI agents. True or false? What do you think? I believe the world of MCP and AI agents is very similar to the world of REST APIs and web apps that we have seen earlier. Now, it's just that most content out there is going to tell you how to build an MCP server, how to connect to your MCP server using your client, using your browser, using your AI coding assistant ID. There are so many conversations around hosts, clients, servers, transport, primitives. But then I believe, as Java developers, what we really need to understand is we have been building the hard part for decades. The engineering discipline is not changing. What we really need to know about MCP as a Java developer is what this video is all about. I have been to certain conferences recently where I got questions like, okay, we have the REST API, which we have built using Spring Boot, we have microservices everywhere. How do we make it accessible to the agents without rewriting everything? So you add a protocol layer. So what follows today is a distillation of all the mental models that I wish a Java developer needs to have first before they start building with MCP server, and more importantly, why your existing REST API is already a MCP server. And we will do a comparative analysis of an existing CRUD app and how we are going to convert that into an MCP server with minimalist, just 3 lines of code. And we will make it accessible to the agent. So if all of this gets you excited, without further ado, let's begin. So if you strip away all the hype, what is an AI agent? There's an LLM, which is the brain, the intelligence, and then there are integrations built around it. And all of this is happening like running in a loop. So it receives a request, it reasons about it, then it will decide, okay, this tool I have to call, or these many tools I have to call. It will get the result, then it'll take another reasoning. Is the result okay? It will evaluate, then maybe call another different tool, and eventually it will respond with what it needs to do. Like whatever it has been asked to do, it is eventually going to respond. So at the very basic, this is what an AI agent is. But the thing about AI agent, as you can understand, is if it needs to take the action, which it has to, because that is what an AI agent is for, it needs tools. Without tools, agents just become chatbots. And with tools, it can actually do the things in the real world. Now, so AI agents need tools. And how do agents find those tools? How do they know what is available, what is not, what are the inputs, what they'll get back? And that is where MCP comes into play. So as I started the video about AI agents and the MCP, the particular statement, what I am right now trying to make you understand the mental model is what AI agent is, what MCP is, how are they connected to each other, and how are they not connected to each other also is what we are going to discuss. So agent needs the tools. The way they are going to find those tools is using this protocol like MCP, Model Context Protocol. It is a standard that will let the agents discover and invoke the tools. In the previous video, I've already talked at length about MCP. Now we are just trying to connect the dots and form the mental models. Now, which brings us to this particular thing which I started the video with. Now, MCP is a capability discovery protocol. Agents, AI agents are just the most visible consumer today. So your ID uses it. Your CLI are also using MCP. ID is getting connected to MCP server. Your command line interface is getting connected to MCP server. Your orchestrators are using it. Dashboards are using it. So the protocol does not really care who is calling it. It just standardizes how the pieces connect to each other. And that is why I made this statement. So think of it like HTTP. Web browsers became the most visible consumers of HTTP. But we also wrote REST APIs to use it. We wrote webhooks to use it. IoT started using APIs. So HTTP does not really care who is calling. Similar analogy. Okay. Now, as many of you might already know that I speak at different conferences and meetups. I went to Java meetups and conferences, and my interaction with the developers, the recurring question has always been that we have been using Spring Boot, microservices everywhere. Now, all of those APIs that we have already written, those microservices which are already written, hosted on cloud, hosted on-prem, how do we make them accessible to agents without rewriting everything? This is the most recurring question that everyone was having, and that is why I just wanted to do this video so that I can talk about or show that you have an existing CRUD app which is talking to the database, doing the work. Now, instead of you going to hit the curl in the postman, how your agent, just by talking to the agent, you can actually make the same thing happen with MCP, with Spring AI. That is the demo that we are going to show. Right now we are talking about mental model for Java developers. So what you also need to understand that what happened before MCP. I have touched upon it briefly in my previous video also. I want to reiterate because we are talking about what mental models Java developers need to have. So before MCP, how did we do this? How did the AI apps talk to the tools? Before MCP existed, how did we do this? How did the AI apps talk to the tools? So OpenAI introduced something called function calling, where you would define the tool schemas inside every API, more like hard-coded, model-specific formats, not going too much into the details. LangChain had its own tool abstraction. Again, schemas were different, life cycle was different. So every single integration had to be written in a different way. And that is what led to the problem of M cross N problem, which is like if you have to connect with M different vendors, you have to write N different integrations, M cross N problem. So if you wanted, so it's like you're writing same integration 4 or 5 times for every vendor. Does it sound familiar to the Java developers? Because I think Java developers have lived through this exact arc. JDBC, JMS, Servlet, JAX-RS. Every generation, the industry converges on a standard that just makes particular problem, this integration problem, kind of invisible. So this is how the industry, the AI industry, has converged on this standard called the MCP. So when we say that MCP is the USB-C for AI integrations for Java developers, MCP to AI agents is what JDBC was or has been to databases. Like before JDBC, every database used to have like different driver API, and then before MCP, every API, AI app was integrating to different vendors, connecting using custom function schemas, plugins, hard-coded integrations, per model, per vendor, all the mess. So this is very important for you to understand what existed before. And obviously these created problems, like if the tools that you were writing then, the methods, functions, tools was the later nomenclature, tools getting tightly coupled in the app, the vendor's tool was not able to talk to each other, then the agents was not able to find the tools at runtime, the logic was getting copied, duplication or redundancy, no reusability of code. All of this duplication efforts and everything. So all these problems led to the AI industry converge on the standard of MCP to solve all of these problems. And if you noticed, by now, most of these problems are solved already. With that, let's talk about the architecture. So MCP has 3 players, and there is client and server, and then there is host. And a very common confusion is, if there is server, why do we need host? What is the difference between the client, the server, and the host? So your host is the AI application that your user is talking to. For example, Cloud Desktop is a host. The VS Code with Copilot is a host. Cursor, Kiro, Goose, which is open source, this is a host. Cursor is a host. Kiro, the Agentic ID, is a host. Goose, an open source tool, is a host. Your Spring Boot application, which is annotated with @Spring Boot application, is also the host. It's like the process that boots up and orchestrates everything inside it. And client, on the other hand, is the connector, which lives inside the host. One client per server. More like a web client equivalent in Spring World. So this gives a clear separation of concern. Like you have separate for user service, different microservices will have different. So you can connect to like client to server, you can connect like one-on-one. So every connection will be isolated, independent. Again, solving the problems that we talked about. Now server, 2 things. In the previous video, we have seen how do we build a server. Today also we are going to kind of see how to convert your REST API to a server. One thing is to build a server. Another thing, to connect to existing MCP servers that you already have to your client application. So the server is what exposes the capabilities, the tools, data, prompts over the protocol. So just to summarize the architecture, there is one host, there are many clients, and there are many servers. They don't share state, they don't crosstalk. And the key separation, like you see the host and the server, is the host has the LLM, the brain, the intelligence, the engine. And server is containing your business logic. Server will contain the tools. MCP server has tools, right? So your MCP server is exposing the tools, the capabilities. Hence, it is also called the capability discovery protocol. So where we talked about all the 3 players, the thing to note is that if you see the flow, the workflow, the user sends a prompt, right? It hits the host, which is your AI application. Now inside that host, as we said, there will be multiple clients for every server that it is talking to, and they're not sharing anything. So if you look at the transport layer, server A and server B, they are the local servers. Server C and server D are the remote ones. So when we talk of like local servers, the transport mode is they're using STDIO, standard input output. No network overhead, latency will be minimal, good for POC development. Now C and D, that they are like the remote servers, so it goes over network. Now in the context of modern AI development, JSON RPC 2.0 serves as the foundational data layer and the messaging format for the model context protocol, as you can see on the image over here. So the JSON RPC layer is going to give you the rules that how the text is going to be serialized and structured on this particular wiring. When I'll show the demo, I'll show the logs also of that particular message format. So it ensures that every command has a predictable schema so that the LLM client can call the functions on any MCP server without custom API wrappers. So as we can see from the image, two types of servers, two types of transport layer. One is the standard input output for the local, and then there is the HTTP, like the streamable HTTP protocol, the transport layer for connecting with the remote MCP servers. So this one diagram should be giving you a good picture about, you have three players, now you have two layers, there are two transport, there are four servers, one protocol. That is the whole architecture which you need to understand. Moving on to what you might be waiting for, the demo. Let me quickly walk you through the demo flow. What we are going to see is we'll start with this simple Spring Boot REST API. It will talk to the database. And then we will add a dependency of @tool on the service method and the config bean and little bit of changes in the pom.xml. And then we are going to connect the AI agent so that we will watch how the tools are getting discovered. We will also see the JSON RPC log messages. And then when we actually talk to the agent, like this fourth thing that book, whatever this prompt is doing, this prompt equivalent first we will see in the older method, the traditional method, like a CRUD app, we go to Postman, we hit it. Or from UI, we are actually hitting a backend API, the REST API. And then over here, we will not basically do a curl command. So we'll just talk to the agent. And the same exact same functionality, the same method or the tool is going to get invoked. So this is what will answer the question that if you have multiple REST APIs already written, how you can convert that to equivalent MCP servers and ensure that your AI agents get access to it, can talk to it without rewriting everything. Alright, so first let me show you the pom.xml. We zoom in a bit. So as you can see, we are on this branch. Okay, so as you can see in the POM, we have a web dependency, JP and H2 dependency and test. That's it. Let me go to the controller, a very simple Spring Boot REST controller over here, where we have certain post and get mappings. And if I just show you the repository, simple plain old H2 for integration with H2 database, the repository, the models, or the entity that we have. And let me also show the service class. And as you can see in the controller, we have the logic written over here. Instead of having the service live just written over here, to do the basic CRUD operation, create the bookings, get the bookings, and how you're using the repository class. So very plain and simple basic Spring Boot application, and I'm sure you would be having many controllers, many mappings, and many service classes, etc. like this, like multiple microservices like this. So if you think of it like each modular thing, right, every method has just one particular functionality that you are trying to achieve. What we essentially want to do is your AI agent, if you want this to be accessible to the AI agent, if you remember the architecture, we have the client and we have the server, right? So now this is what the server is exposing, the capabilities in terms of these methods. Now, if your client wants to invoke this over here, so your client in this case is the AI agent. Now your client, your AI agent wants to invoke this particular, we say the tools or the methods or the functionality. So it anyway has to do this particular API call, right? So what we are going to do with the help of this particular integration is that one demo, like the first flow is that we are going to do it in the traditional way. As I said, we'll go to Postman, we'll do a curl and we'll hit it. Second, we'll refactor this particular code base in 3 simple steps. What are the 3 steps? I'll show you what are the things that will convert this particular thing into an MCP server. And then the same AI agent, which is going to invoke it, is going to invoke the same, like the multiple So now the AI agent is going to invoke the MCP server, and then it is going to just access the same functionality. So the functionality remains the same. How they are accessing is going to change. Now when I say MCP client, in this case is the AI agent. Now your MCP client could also be the MCP inspector, which is the postman equivalent. So it is also going to access, I'm going to show you both the things, the MCP inspector also and the programmatic MCP client as well. So with that, what I'll do is, let me start the server. The server is started on port 8083. I'm just going to hit a couple of endpoints just to get the packages, and let me create a new booking in the name of this customer. Now I'm going to go to the H2 console. So here we have this particular table, and as you can see here that we have been able to create a booking. Now all of this we did in the traditional way. So now we are going to see what are the 3 steps that you need to take to convert this into MCP server. So I'll go to the GitHub. So this is the GitHub repo which has all the steps, everything that I'm doing. So how to build an MCP server, convert an existing code base. You just need 3 steps. One is you're going to add this particular dependency, and which will be available on the MCP endpoint, and these are the properties. So let me show you these changes that I've done. The first thing, as we have seen, is this is the Spring AI dependency that we have added, which is going to be available over the streamable HTTP support, transport, and everything else remains the same, the data JPA, H2, etc., etc. What is the next step? So next step is you have to annotate the methods, like whatever is containing a business logic, with @tool and @tool paro. So if I go to, there is a new package called tool, and here we have different tools. So the controller that we had seen, if you remember the CRUD app, CRUD logic, the create booking, get booking, all of this, the same logic is here, just that now we have annotated with this @tool, and in the @tool param we are passing in the parameters that it is going to take in. Everything else remains the same. And then we have some more tools that we have exposed. So now this entire code base is now functioning as an MCP server. So this is step number 2, one in the POM. Second is this changes to the business logic. Third is in the resources that you are going to, actually the POM changes and the resources have combined that as one step only. So in this resources, if you see this highlighted portion, this is the change that we have added. We have added a name, we have added, this is the protocol. And over here for some logging, for detailed JSON RPC message exchange logging, we have added this logging level properties as well. And the third and the final change is you have this configuration file, which is the most important. Here we have registered the tools that we are exposing. In this case, I have some more tools for the business logic supported, and all of that has been registered over here. I'm going to link down below the blogs also, which talks about in depth about what every class does when you're building the agent. So there is a multi-part series, like a blog series. So I'm going to link the blog as well. Make sure you give it a read. So now that we have seen, these are the steps that we have done over here, registering tools. So what happens under the hood? Like I'm going to show you in the logs as well. So as we know, MCP uses the JSON RPC 2.0, and every message you will see is a JSON object which will have method, params and ID. So when it says initially, it will initialize it. It will pass in the session ID, the capability. Then before even calling a tool, it is going to check what are the available tools or registered tools with the schema. Then it is going to do the tools call and give you the tool execution result. So the benefit of using Spring AI is all of this thing, plumbing, is being handled. You don't have to write any JSON RPC handling. You're not building a new app, you're exposing the existing logic through the standard protocol. So the same tool that worked locally will now work remotely. This is the main difference that we are trying to expose over a remote MCP server. Right now this server is running locally, but when you host it, it is going to run over remote MCP server, right? And also the thing is, we are going to see that how 2 types of MCP client are going to connect, right? One, the MCP inspector, and second, the MCP client, which is programmatically written, which is another Spring Boot, Spring AI app rather, I can say. What I was actually saying about the architecture is something like this we are going to do. We know that the server is running on 8083, and through this particular streamable HTTP transport mode, through this we are going to test 2 different clients. So MCP client 1, which is going to be an programmatic agent which is going to run on 8081. We'll start that. First, I'm going to show you with the MCP inspector. Okay. So there's one MCP server, multiple clients. So I'm a human, I'm using the inspector. And then there will be an AI agent which will have the GUI, the interface through which we are going to talk. Both are connecting to the same /MCP endpoint. There will be different session IDs. It will connect to the same MCP server. Okay, so now what we are going to do is, let me start the server first. Okay, so this has started on 8083. Let me show you some logs. So as you can see, registered tools over here, it is showing 10 and H2 console is available. Let me go to the MCP inspector now. So over here I'll select streamable HTTP. We will connect to 8083/MCP. Okay, so we are connected to this server now. I'll go on tools and I'll click on tools. And then before I click on this list tools, let me show you the logs. As you can see over here, very first thing, like we had shown that we are initializing this received JSON message. So the method is initialize. If you remember in the GitHub repo, we had shown this thing that the first method will be initialized, then tools/list and tools call. So that is what is happening over here. The client has initialized the request, has received the JSON message over here, and then this is the session ID. Okay. Now we will go to list tools, and as you can see, all the tools that was exposed in the code is now being shown over here. And yeah, so back to the logs. Here, if you notice this logs, this is doing tools list. So first it was initialized, now it is tools list. So now what is supposed to happen is, if I click on any of the tools which is supposed to run, it will now show the tool/list. So let me call a simple tool, maybe get current date time. So the tool result is a success. And if I show you this particular logs, tool/call, and this is the name of the tool which was invoked. And then the starting execution of the tool, successful execution, and all of the logs that you can see. So now we have tested this particular server like a Postman equivalent, which is the MCP inspector. Now I'm going to start the agent. In the previous video, I have also shown that particular programmatically created Spring AI agent. And let me go and start that. Okay, so this is the GitHub. So this is the programmatic Spring AI chat client. People who have seen the previous videos of this playlist, AI Engineering for Java Developers, will be able to relate when I open the interface. So let me start the server. And while the server starts, let me show the application properties. As you can see, let me scroll down. Yeah, so line number 28, this is what is making the connection between the client and the server, as I've put the 8080, the one on which our server is running. Tool callback enabled. So these are the settings which we have, the properties that we have added over here. So with that being done, what we are going to do is, we are going to go to this particular, so there's a chat UI which will be connected. So what is going to happen is, I am going to ensure by showing you the logs, I'm going to show you that. First, let me show the logs of how this client and server is connected. Highlighted lines, if you see that, method initialize, protocol version, client info, unicorn rentals chat client, the one which was shown over there. See over here, the name is unicorn rentals chat client. And it has done the initialization, and you can see that this has a different session ID as well. So the MCP inspector has a different session ID. This one has a separate session ID. Now let me go to 8081 port where the MCP client 1 is running. Okay, so first I'm going to, okay, so remember in the Postman, we were having some endpoints like list all the packages and all of list all bookings. So the customer name we had checked was or for Varsha. So essentially it is supposed to query the database and get me if there is any booking there or not. If not, we are going to do a fresh booking, and there is no booking. So this is what was there in our, because the database is getting initialized, it's empty, right? Now what we are going to do is, we are going to send that particular prompt. So I'll just say book a rainbow package for Varsha on July 15th for 2 hours. Okay, so this is done. Now let me show you the logs of the on the server side. So two things. One is, it did a tools call of create booking, and before that, if you see, a lot of tool call has happened, right? So one is getting the pricing rules happened, and before that it did a get bookings first, then it did a get pricing rules, then it did this date reference of the date it asked me, 2024, 2026, then create booking, and finally it has successfully executed. So the very first slide where we said that AI agents are integrations running with a loop, this is what it exactly shows. There were results you were getting. It was getting the result of the tool, feeding it into another, reasoning it, and then giving me final result. So now the Most important part is, let's go to the database and check if the booking has been made. This is the table, and as you can see, this has been created at exactly, this is the time on my laptop as well, right? So with that, I think we are going to wrap up today's video. The code of this will be available on the GitHub. So that is what the goal of this video was. Hope you all have got some value out of it. So if this was useful, like, subscribe, share it with any fellow Java developer who is building this side of things already. Follow my playlist AI Engineering for Java Developers, and the code repos are in the description, and I'm going to link the blogs also in the description. Thank you so much for watching. Stay tuned for more videos like this. Let me know in the comments what you want to watch next. Thank you so much.